You know, it's funny, folks. I tend to save, as you can tell, it's dark outside. I tend to save my after hours for doing certain things. Questions come in my mind, things that I see. And tonight, I think it's about 11 o'clock. Actually, it's 11:15. I'm going to show you guys something which is going to be a precursor to an upcoming video. I actually made a video about this several years ago. Seems to be forgotten, but this topic seems to come up again. So I'm going to show you guys just a precursor for what's coming. I like to answer all questions for the naysayers and that sort of thing. You're going to see me fixture up a sprocket shaft of a stock Harley crankshaft. Just the sprocket shaft that I've cut up just to make it easier to see. Now, you're going to see I'm doing this in my lathe, and I want to show you what I've done. In order for these measurements to be accurate, we have to have an accurate center line to prove my point. Now, I do have a tool post grinder. My 3-jaw chuck has been ground, but to eliminate that as a variable, I have machined what is going to be a dead center, and it has stayed within my chuck. I machined it here and machined the taper. So I'm center line to the rotating assembly based on the machining. What I also did with my tailstock is I drilled a hole right in the end so that I could then run my live center into the middle of this dead center to demonstrate that both of these centers are lined up. Now let's do that. And I've got it locked. Boom, boom. Now let's see if we line up. And look at that. We're dead on the money. Now, just to be sure, there's another little tidbit, another little thing I can do, is I can take, let me see if I can do this with one hand. I'm going to put this in neutral. I'm actually going to back off on my chuck a little bit. Back off just a hair. Alright, now let's take and stab that center just like that. We're going to allow it to move and slip in the chuck just a little. Alright, now we're going to rotate it around, and you can see we are dead center of that pilot hole. Now, let me lock my chuck back down. I promise, guys, you're going to see where I'm going with this. Let's answer some questions. That's what I'm all about here. Alright, yeah, I'm using this, not a T-handle, because I want it good and tight. Don't give me crap about that, I really don't care. You can see we're dead on that center, right there. Now, let's back this out, and let me set up the next thing. Now that you know the basis of this, let me set up the next step to explain. This is a machined up sprocket shaft from a factory Harley crank. Yeah, it looks kind of interesting and cut up, right? I had a bunch of scrap crank halves, so I needed some extra tools to set up and play on tapered main bearings. So instead of buying this and welding and this and that, I just took one of the sprocket shaft halves, dropped it in the mill, cut it up, dropped it in the mill. This fits in a vise, and that's, let's just grab something at random off the shelf, in other words, right? So this is the PTO side of a crank. You'll see here, that is the bolt hole where your compensating sprocket would go, and that is a taper because there have to be machined some way. The question is, this surface here, which is where your bearing race goes, relative to the center hole. After I show you what I'm about to show you, then I'll reveal what I'm talking about. Alright, I already showed you. This is on center line of the crankshaft. This is on center line back here. Center line being what was initially used to machine and possibly cut the splines. This is a problem with the stock crankshafts. Notice the gauge. Remember, this is the surface that your bearing race goes on and the surface that rides in the case. Notice, we are supposedly, quote, air quotes, on the geometric center line of this half. Yet, look at that. That bearing surface is 2.5. That is a half thou gauge. 2.5, almost 3 thou, actually, right at 3 thou. Out of concentricity with the geometric supposed center line. Hang with me, I want to show you something else. Now I know this may look crazy to you. I'm actually going to do it here in a second in slow motion. I've got a button head on here. I'm riding directly on top of the splines, which is technically speaking where your compensating sprocket is going to ride. Watch the gauge. Now let me do it in slow motion. What I can see, because I'm used to looking at it, is 6 to almost 14 thousandths. That's almost an 7 to 8 thousandths out of round on the splines. So let's do this in slow motion real quick so you can see it. So in essence, what's my point here? My point is the actual issue with the factory crankshafts isn't necessarily that they didn't grind them from centerline. They did. But the problem was when they drilled the hole at the end of the sprocket shaft, a lot of those holes got drilled off center. So if that hole is off center, your splines relative to that are off center. I'm showing you this in essentially reverse. If we have that sprocket shaft side, which is equally as important as the pinion shaft side, what I've shown you here is I have set up a perfect geometric center line, yet the bearing surface, or what would be the surface for your bearing race, is off center from geometric center line of the crankshaft by 2 to 3 thou. The splines are off center, 7 thousandths. So in other words, it doesn't necessarily mean the crank was ground off center. It means that when they did that punch of the hole, final hole through the middle, and threaded and drilled the big hole at the end of your crank, those holes got drilled off center. This started happening in 2007. This isn't new, guys. And I'll post a link in the comment down below that will reference a video I did several years ago, and there were naysayers saying I was crazy. Well, guess what? I'm not crazy. So the problems you're seeing with crankshafts now are not anything new, guys. This has been going on since '07, and this is one of the challenges with stock cranks. So if that center line is off, everything else can be off as well. So it's critical that this dimension be checked. If that hole is off center line, the center line is off, the compensator is out of concentricity with the crank, and that can cause other issues. So stay tuned. I'm going to do a more extensive video on this with complete flywheel halves, assemblies, and stuff like that. We'll talk to you soon. I think I'm going to go get some sleep. We'll see you.